Good morning dear students, welcome to Tayal tutorial. So today for the topic of discussion is alternating voltage which is being fed your electrical component like resistor, inductor and capacitor. We will see all the behavior of your these three component when it is being fed to that alternating voltage. See, this is your inductor and this is AC voltage source is being supplied to that inductor. Okay, so now when that AC voltage source is being applied, so what will be the EMF and what will be the alternating current and what will be the your peak value of current, we have to see. We will see how that behavior of phase voltage, how it's lead and lag, all the things we will discuss. Okay, so see what happened. This is your and the instantaneous value of alternating EMF when that AC voltage is being supplied to your your inductor, where E naught is your average value and omega is the frequency of the source frequency. Let's see, you can write AC voltage source. Let's say यहाँ पे आपका Vm sin omega naught t अगर आपने यहाँ पे सप्लाई किया तो यहाँ पे समझो कि E naught sin omega naught t will be the EMF. ठीक है. So let's say next the instantaneous value of alternating current is equal to I is equal to y naught sin omega t minus of pi by t. We will discuss this how this is pi by 2. Okay, this is your, you can say that V is equal to Vm E sin omega t V applied. Okay, where the peak value of your this is peak value of your current I naught is equal to E naught by omega L, where omega is the frequency of the source. Now inductive reactance, what is that inductive reactance? XL. We represent that inductive reactance with the letter XL. So you can see that how this is inductive reactance is, what are the different properties and how it behaves with the circuit. C. Some of the important points I am writing over here. Inductive reactance, the quantity omega L quantity XL is equal to omega L is analogous to resistor and it is called reactance of inductor, and it is being represented by XL. It is being represented by XL. Now what happened that in pure inductor, okay, in pure inductor your current will lags the voltage by 90 degree. In pure inductor the current will lags voltage by 90 degree. See, जितने भी आप फॉरेन ये ब्रिटिश राइटर्स के बुक्स देखेंगे वहाँ पे हर इस तरीके से ही मेंशन है और हम लोग यही स्टैंडर्ड को फॉलो करते हैं. इन रजिस्टर द वोल्टेज एंड करंट विल बी इन फेज, इन सेम फेज, दे विल बी सेम फेज. आई विल टॉक अबाउट व्हाट इज द मीनिंग ऑफ सेम फेज. ओके, सो बट इन inductor the current lags the voltage by 90 degree pure. Okay, in pure capacitor the current leads the voltage by 90 degree. But when you see that some books, okay, in some books you might not have noticed that but in some book what happened, they written that an inductor current leads the voltage by 90 degree. When you see that kind of book, you should tell yourself this book is being written by German writer. Okay, there is nothing wrong in that because these are the assumptions, but we follow that British assumption because we are being ruled by them. ओके उनकी कन्वेंशंस को हम फॉलो करते आ रहे हैं. इन प्योर इंडक्टर करंट लैग्स द वोल्टेज बाय 90 डिग्री. इन प्योर कैपेसिटर करंट लीड्स द वोल्टेज बाय 90 डिग्री. इन रजिस्टर करंट एंड वोल्टेज आर इन फेज. आई विल टॉक अबाउट दीज थिंग्स. सो फर्स्ट आई एम डिस्कसिंग दैट इंडक्टर बिहेवियर. So this is being represented by XL. Now the value of XL, we can write that value of XL, which is equal to XL is equal to 2 pi L, which is also equal to omega L, which is equal to 2 pi F into L. Now, so what happened? It will bypass XL is equal to omega L. It will bypass what? DC. Okay, so what happened when you put F0, DC the frequency is 0. When you put 0, XL is equal to what? 0. Okay, so what happened? It bypassed DC, this reactance, inductive reactance XL. It bypass DC, but offer finite resistance, to the flow of AC, to the flow of AC. Okay, now let me show the phasor diagram, how that inductor and how that voltage and current is varying when that AC voltage is being applied to the inductor. Okay, before that, small idea about lead and lag. Okay, let's see. So what happened? We are following that convention. In a pure inductor, current lags the voltage by 90 degree. In pure capacitor, current leads the voltage by 90 degree. In a resistor, voltage and current will be in phase. These are the convention, we follow that. So what is lead and lag? Let's see. For saying that something is leading or lagging, we have to take something as a reference. Okay, so we are taking, this is a voltage source, thus just a voltage. Okay, if I want to say that current is lagging, so what I will do, I will write in that way. Means what? In clockwise direction. Lag, it's clockwise direction. Lead, anti-clockwise direction. These are the convention you have to follow. लैग कर रहा है कोई भी क्वांटिटी, वोल्टेज अगर करंट अगर वोल्टेज से लैग कर रहा है तो फिक्स दैट वोल्टेज and bring that I with respect to 90 degree of that will be your lag and lead. So lag, rotate the phasor in what? Clockwise direction, clockwise. And if you see lead, rotate that in anti-clockwise direction, anti-clockwise direction. Fine. Now what happened? Let me show you the phasor diagram, how that voltage and current behaves when that AC is being applied on that inductor. Okay, let's see how that phasor is behaving. See that E was, that will help you, E was E naught sine of omega t, I is equal to I naught sine of omega t minus of pi by 2. That was our instantaneous value of voltage, EMF and what? Current. Okay, let's see how that diagram will go. So I am just drawing. This is how our reference line is there, which is omega t. Now for voltage and current behavior I have to show. Let's see, E is equal to E naught sine omega t. So this is a sinusoidal function. So I am just drawing that sinusoidal. This is how. Let's see, if this is 0, this is what? Pi by pi. This is what? 2 pi. Now if this is pi, in between middle somewhere it is pi by 2. Okay, so we are writing pi by 2, and this is in between somewhere 3 pi by 2, 3 pi by 2. Now we see that voltage is what? E naught sin omega t, but current I is equal to I naught sin omega t minus of pi by 2. Means what? This negative sign is saying that your current will lags the voltage by 90 degree. Means what happened? First the maxima of your voltage will reach that voltage of maxima of voltage, first it will come. After that maxima of your current will come after 90 degree. You can see that how it will come. See, this is your what? EMF. This is your EMF. Now next the voltage, can see that this is voltage. Now the value of the graph of current, how it will be. So what happened? It is saying that your current will lags the voltage by 90 degree. So this you can see that this diagram, this location from here to here, this is pi by 2, means what? This is 90 degree. So what happened? If my maximum voltage is here at pi by 2, so my minima of current will be at pi by 2. That will satisfy that equation, I think. Okay, so I'm just drawing that value, that graph. This is how you can see that there is what? Lag of your what? Lag of your current. This is what? This is current. Your voltage or EMF is being started from over here 0, but your current is started from here pi by 2. So this is your lag. This part is lag. Your mathematical expression, this your phasor diagram is this is your graphical representation is just satisfying that your current is lagging your what? Voltage by 90 degree. This is pi by 2, this is 180 by 2, this is 90 degree. So this is how the voltage will be. Now I want to represent with phasor. You can see that same diagram. I want to represent with this phasor. See, this is, I am writing the voltage across inductor as a notation VL, voltage across inductor, which is being represented by VL, V suffix L, capital L. So this is your VL. If I have marked that VL over here, this is VL, and you know lag means what? Anti-clock, and lead means what? Sorry, lag means clockwise, anti-clock means what? Lead. Okay, so if this is VL, I want to represent where is the value of current IL. So it will be somewhere here or here. So my idea is that it should lag the voltage by 90 degree. So it may be here 90 degree, it may be here, but it may be here. But when it comes to the lag, it will be what? In clockwise direction. Okay, so what happened? You have to write your value location of your current, not in that way. You have to write that current here. See that this is your current, current IL, current flowing through the inductor, voltage across inductor. This is how 90 degrees fixed. Anybody can draw that here or here, but when it comes to the inductor, your current will lag the voltage by 90 degree. So to represent that, I am writing that this is what? Pi by 2. This is how inductor is behaving. So for the sake of clearance, I am just writing one statement. The alternating current lags the voltage by 90 degree. Alternating current lags the voltage by lags the voltage behind 90 degree, or alternating EMF maybe leads. You can say that same thing. You can write that voltage EMF maybe better write all everywhere I have written EMF, so better write EMF lags the EMF by 90 degree, or when you say your voltage will leads EMF will leads the IL by 90 degree, that is also correct. When you keep this is fixed, if you want to say about this is lead. If you want to keep this fixed, if you want to say that this is lag, remember that this is clockwise, it's a lag, anti-clockwise, it's a lead, positive. These are the conventions which is being followed from long back, but you have to follow that actually. But don't get confused if you find some book in inductor current leads the voltage by 90 degree. That book is written by different country author. Don't follow that. Okay, your examination always follow that these things. Your inductor current lags the voltage by 90 degree. Okay, see, this is how your behavior of voltage and current in your what inductor. Now next I want to write the power which is being supplied to inductor. The topic will be power supplied to inductor. Power supplied to an inductor. Power supplied to an inductor. Okay. And the instantaneous power which is supplied to the inductor is equal to PL. This is L for inductor. This is instantaneous power which is being supplied to your inductor is equal to I and to V. I, you know, Im what? Im sin omega t minus pi by 2, where Im is the peak value of current. Okay, I is equal to Im sin of omega t minus of pi by 2. You know why omega t minus pi by 2? Because in inductor current lags the voltage by 90 degree. So this is Im, the peak value of current, into sine of omega t minus of pi by 2. Minus is because that current is lagging the voltage by 90 degree. This is how omega t minus pi by 2. Now what happened? Next, your Vm, this is Vm sine of omega t. Okay, so what happened in mathematics? We have studied that sine omega t minus pi by 2. In sine omega t minus pi by 2, you will have minus of cos omega t. Okay, so when you write that, this is what Im minus of cos of omega t into what? Vm sine of omega t. When you multiply, you will get some value. What happened? Minus of Im Vm, this is better, Im Vm cos of omega t into sine of omega t. This is how we got. Okay, minus of Im Vm cos omega t sin omega t. Now what you can do, multiply by 1 by 2, multiply by 2 and divide by 2. So what happened? Minus of Im Vm by 2, and this is your 2 cos of omega t into sine of omega t. And we know that in trigonometry 2 cos A into sine B is equal to cos 2A. So when you write further, what happened? When you write further, this equation will come PL is equal to what minus of Im Vm sine of 2 omega t, 2 cos A into cos B sine 2a, or 2 cos omega t into sine omega t, what happened, sine 2 omega t. So what happened, Im Vm sine 2 omega t. This is double frequency component. Okay, so since the average value of sine 2 omega t, average value of sine 2 omega 2 over a cycle is 0, so the value of average value of, since this is average value of this edge 0, so your PL will be 0. PL will be 0. Okay, thus the average power supplied to an inductor is 0. This is the conclusion. Okay, so what we have studied, that current, voltage and the power relations. The final result is average power supplied to the inductor is 0, because your average value of sine omega t will be 0. How it is coming, you can see omega t minus pi by 2, this is how. Now this is omega minus, this is omega t minus pi by 2 minus cos omega t, this is minus 2, we have divided by 2, multiply by 2, we got that value 2 cos omega t into sine omega t. Now that minus of Im omega minus Im Vm sine 2 omega t, and this is over a cycle, the average value will be 0. So this is your final result. Okay, so let's stop over here. We will see in next class the behavior of resistor and capacitor in next class. Thank you so much.